Hello everyone, this is FRQ number 4. So, A asked to draw a free body diagram for block M1. So, this is the block, and this is okay. So, let me move this a little to the right. Okay, so tension 1 is pulling it to the left, and tension 2 is pulling it to the right. And then there's also an Fn and Fg. This is a bird's eye view. So Fn will be like, let's say that Fn is a small circle. This is Fn. And that Fn is pointing straight up. But from the bird's eye view, it'll be like this way. And then the square is in Fg. And it will be pointing down to the to the surface, and Fn will be pointing away from it. So that's part A. So this is part B. So part B asks for a free body diagram for block 2. So M2. There's only tension. There's only the second string on it. So we just point this way, and this is T2. And then the circle and square. The Fn is pointing up to the surface, like away from the surface, and Fg is pointing down into the surface. Part C asked to calculate the time for the second block. So we know that velocity is equal to 2 pi r, which is the radius, over time. So you multiply t over and divide by v, so you get t is equal to 2 pi r over v. Velocity is given as 4, so t is equal to 2 pi 4 and over 4, and r is 0.75 meters. And when you plug this into your calculator, you get about 1.18 seconds. So part T asks to calculate this tangential speed for M1. So using the same formula as before, V is equal to 2 pi r over t. We know that the radius between the center and M1 is 0.4 meters. So and we also know that the what's it called? We know that the the time, we know the time is 1.18 seconds from the previous part. And when you plug this into your calculator, you should get about 2.13 m over s. Let me write the part E asks to derive centripetal acceleration in terms of r and t. So we know that v is equal to 2 pi r, and a of r is equal to v squared over r. We're looking for AR of the inner block, so the R is R1. So V squared, we plug in 2 pi R over T. So AR is equal to U squared at the top, and then you should get AR is equal to 4 pi squared R1 squared over T squared divided by R1. So we can move the squares. So we move the square up, so we can move the R1 and T squared are in the same spot, or the same denominator, so and then the R1 cancels out with the square, so AR is equal to 4 pi squared R1 over T squared. Let me fix this to make it a T. And that is part E. Part F asks to find AC M1 over AC M2. So AC, so we know that AC and AR are equal to each other, and we know that AR is 4 pi squared R1 over T squared. So, and we're looking for AC M1 over AC M2. So AC is equal to 4 pi R1 over 4 pi squared are 2 t squared. The 4 pi squared and t squared cancel out, so it'll be equivalent to r1 over r2. So r1 is equal to 0.4 and r2 is 0.75. And that gives us 0.533 after we plug it into our calculator. And that's the ratio between ACM1 and ACM2. So G asks the ratio for FCM1 and FCM2. So FC is equal to M times AC and then so FCM1 over FC, so FC over FCM1 over FCM2 is equal to M1 AC 1 over M2 AC 2 and M1 over, I'll break up into V squared over R 1 and V squared over R2, but the V squared over R1 and V squared over R2. The velocity for each block is different, so this will be V1 squared. This will be V2 squared. And when you plug this in, you plug in the numbers, so the first block is 0.05 times V1, we solve 2.13. And we divide that by R1, which is 0.4. And M2 is 0.03. And the velocity is given as 4. And divide by 0.75. And after you plug this in your calculator, you get 0.886 as the ratio between FCM1 and FCM2. H asks to find the tension of T1, so I'm going to organize it into the net force of M2 and the force on M1. So FC is equal to T1 minus T2 for M1, and FC is equal to T2 for M2. So we know FC is equal to M2 V2 squared over R2, and that's equal to T2. You plug it in as T2 is equal to 0.0 0.034 squared over 0.75. You plug that into your calculator. And you get T2 is equal to 0.64. And then you can sub it, and then for M1 you can sub in FC is equal to 2T, so T2, so T2 equals T1 minus T2, so 2T2 is equal to T1, and then 2 times 0.64 is 1.2. Is equal to T1, so T1 is equal to 1.28. Wait, no, wait. That's actually wrong, because the FC for M1 is different from FC of M2. So that means that M1 V1 squared. I mean that M1 V1 squared over R1 is equal to T1 minus T2. So 0.05 times 2.13 times 0.4 plus T2 is equal to T1. We know that T2 is 0.64, so and if you plug in all these numbers in your calculator, you should get Yet T1 is equal to about 1.21 newtons, and T2 is 0.64 newtons. So H is here, and I is asking for the magnitude of tension 2, so I is T2 is equal to 0.64 newtons. J asks to determine the magnitude of the net force acting on the inner block. So net force is equal so net force is equal to Fc, and Fc is equal to T1 minus T2 for M1. We know the values for T1 and T1 and T2. So it'll be 1.21 minus 0.64. And when you subtract them, you should get about 0.57 newtons. K asks if the system is replaced with more massive blocks, how will T1 and T2 change? So looking back over here, if we were to make both blocks more massive, which means increasing their kilograms, both of the tensions would increase, because if M2 would increase, if M2 increases, then you multiply by a bigger factor, which means that T2 would increase, and T1 is the same, because because M1 works the same, where if M1 is bigger, then you multiply with a bigger number, and when you do that, you would get a bigger tension for 1, and you're adding it with a bigger tension 2, so that means that T1 will be greater. So that means that both of the blocks would increase. And this is FRQ number 4.